Today we will discuss about complex number. Complex number, a very new topic. But whenever the term number, for the term number, we can recall a common word, real number. So every time for number, we can recall real number. Because so far we know all the numbers that belong to the family of real numbers. Whether it is even, that is real. Whether it is odd, that is real. Whether it is prime, that is real. Whether it is composite, that is real. Whether it is rational, that is real. Whether it is irrational, that is real. That means all type of numbers. So far you know all are real numbers. For whole number, that is real number. That is real number. For integers, that is real number. For fractions, that is real number. Those are real numbers. That means every number known to us are real numbers. But here, now we'll introduce a new topic, that is complex number. So what is the significance of this number? A complex number actually is the composition of two parts, one real and another imaginary bow. A question is here. What is imaginary? All we know real number. So what is imaginary number? So first of all, let us define imaginary number from the help of real number. Because imaginary means the opposite meaning of real. So if we can specifically define a real number, there is no problem to define an imaginary number. So our first object will be to define a real number mathematically, more specifically. What is real number? If anyone be asked, the general answer for the lower class is, that means for up to standard 8 or up to class 6, the answer was a number which can be placed along a number line, along the real number line. Now another question will arise there. What is real number line? So the line introducing real numbers. Oh, that means specifically we can't manage real numbers here. Mathematically, if we want to define a real number, the characteristic of all such numbers that are known to us so far, the common characteristic is their square is non-negative. Think about it. All the numbers you know so far are such that their square are non-negative. So if we consider that R as the set of real numbers, the collection of real numbers, then simply we can say for any number x belonging to that set, that means if a number x is a real number, then its square must be non-negative. So x square is not less than 0. This is the mathematical definition of real number. The mathematical definition of real number is that square is non-negative. And non-negative means, on the other hand, we can express this as this x square is greater equals 0. So a real number is a number whose square is non-negative, that is whose square is greater equals 0. Very pleasant definition is this. That if a number is satisfies the characteristic that is square is greater equals 0 or not less than 0, that is a real number. Plus, no problem is there. So what is the opposite of real? The opposite of real is imaginary. And how can you introduce an imaginary number? How can you define an imaginary number? Can you say what may be the definition of an imaginary number? Yes, of course. Since imaginary is the opposite of real, so its definition must satisfy the opposite characteristic of this. That means for an imaginary number, the square must be less than 0. For an imaginary number, its square must be less than 0. Since for real number the square is not less than 0, the opposite is real, that is imaginary. For that imaginary number, the square must be greater than less than 0. So if we consider y as such a number which is not real, that means which does not belong to the set of real numbers, which is not a real, then simply we can say the square of y is less than 0. Good. So clear? Mathematical definition is very clear. For real number, the square is not less than 0. For imaginary number, the square is less than 0. Now, what is the expression? How can we express this imaginary number? Because all the numbers known to us are real number. So, what is the presentation of an imaginary number? How can we present it? Let us follow that part. Since y square is less than 0, we can consider y square as minus m square, where m is real but non-zero real. What is the significance of non-zero real? Non-zero real means non-zero real. What is this? The definition of real number is that its square is greater or equals 0. The definition of real number is its square is greater or equals 0. And there is a single number whose square is 0. Of course, that is 0, right? So, since the square of 0 is 0, so for all the real numbers except 0, other than 0, their square must be greater than 0. So, if we consider such an m which is non-zero real number, then simply we can say the square of m, that is m square, is greater than 0, so that the whole product, that minus m square, that is y square, this is less than 0. So this is the imaginary number can be expressed as. Now what is y? This is y square. Now what is y? How can we express y? Let us follow these steps. Here y equals plus minus root under minus m square. Clear? That's equals plus minus root under m square into minus 1. Right? That's equals plus minus root under m square into root under minus 1. So what is this? This equals plus minus m into root under minus 1. Plus minus m into root under minus 1. This is the actual presentation of an imaginary number. What is this? Here, this m being real, plus minus m is real, but all we know that the total result, that is y, is non-real. That means from this result we can conclude that if any real number be multiplied by this factor, then that number will become an imaginary number. So multiplication of a real number by this factor is an imaginary number. The resultant of the multiplication of any real number by this factor is an imaginary number. That's why this factor is called the imaginary factor. This root under minus 1 is called the imaginary factor. This root under minus 1 is called the imaginary factor. And so, in general, we will introduce this root under minus 1, or we will express this root under minus 1. We will denote this root under minus 1 as small I of English alphabet. So, if any real number be multiplied by that I, then that number will be an imaginary number. If any real number be multiplied by I, then that number will be an imaginary number. So what is I? That means I equals root under minus 1. This implies I square equals minus 1. This is the significance of real number, imaginary number, and from today we can express any imaginary number. But our topic is complex number, which is composed of two parts, one real and imaginary. Now, so how can we express that complex number? Since complex number is the composition of two parts, one real and imaginary, considering a new number z composed of two parts x plus iy, where x and y are real and I equals root under minus 1 is known as a complex number. This is the definition of a complex number. What is the definition? The expression will be in the form of x plus iy, where x and y both are real, but I equals root under minus 1. This is a complex number. So for any complex number, there will be two parts, one real and imaginary part. Now, what is the real part of this complex number, and what is imaginary part? Let me see it. The real part. Here, this x, this is the real part of the complex number. So we'll introduce this x as Re of z, that is the real part of z. And what is imaginary part of z? Anyone can say this iy is the imaginary part. No, not at all. Because I is the imaginary factor. Everywhere the I will be there. The imaginary part is the real y, which itself is real. But being a multiplier to I, it is the imaginary part of z. So for the form of a complex number x plus iy, x is the real part of z and y is the imaginary part of z. X is the real z and y is the imaginary z when the z is in the pattern of x plus iy. Again a question will arise. For every real number, all we know that the number is a point. The number is a point in the number line. Every real number can be expressed as a point. So the geometrical significance of a real number is a point. So what's that for imaginary number? What's that for complex number? Let me see. If we consider two mutually perpendicular axes, one as the vertical axis and another as the horizontal axis, the horizontal axis is the number line. We introduce the number line along the horizontal axis, horizontal line, as a horizontal line. So considering this horizontal line as the real axis and the vertical line as the imaginary axis, we can express any complex number in this plane. Imaginary, first of all, real number. Any real number can be placed here. Any real number can be placed here. Any imaginary number. Imaginary number means the real part is 0. So how can we express? First of all, let me see. How can we express this x plus iy in this plane? If a plane be considered in such a pattern that depending upon two mutually perpendicular lines as where the horizontal line be treated as the real axis and the vertical as the imaginary axis, then for the complex number x plus iy, first of all we have to consider x along the real line and then the y distance from the real line above it. The position of that point will be that z representing x plus iy, that is the point xy in Cartesian system. Here this will represent that point z equals x plus iy, the complex number z equals x plus iy. That means a complex number is again a point only. So every number is a point. The geometrical presentation of every number is that it is a point. Here, for the plane, here that plane which denotes the position of any complex number, that plane is termed as complex plane or Argand plane. If a plane will introduce all the complex number, then that plane is called Argand plane. So which type of points will be there? That means which type of numbers are complex number? Is it only in the form of x plus iy? Let me check it. If we consider a question is for you, suppose 4 is a number, can we say that 4 is a complex number? Everyone will say 4 is real number, right? 4 is real number. But is it a complex number? Yes or no? Since we can express this 4 equals 4 plus I into 0, where 4 and 0 belongs to R and I equals root under minus 1, which satisfies the definition of complex number. So simply we can say, yes, 4 is a complex number also. So 4, as well it is a real number, it is complex number also. That means, although we know that every number, rational, irrational, imaginary, even, odd, prime, composite, whole, integer, fraction, all are real numbers. That means the real number is the grand number system, but not that all. There is a grand of that, and that is complex number. So if real number is the father of numbers, or you know so far, complex number is the grandfather of all the numbers. That means every number, real number, is one type of complex number also. So from that definition, we can conclude that complex number are of two types. One, a general complex number, which is in the pattern of x plus iy, and another, purely real complex number. These type of numbers which are purely real but complex number. Purely real complex number. These are known as purely real complex number. What is the significance? What is the characteristics of this type of number? Here the imaginary part is 0. So one, general complex number in the form of x plus iy. Another, purely real complex number where the imaginary part is 0. So what for imaginary numbers? If 7i, we consider this number, this is imaginary number because 7 is real. All you know that 7 is real, and here I is multiplied to 7. So 7i clearly will become an imaginary number according to our definition. So what is the position of 7i? Say for 7i we can write 7i as 0 plus I into 7, where 0 and 7 belongs to R and I equals root under minus 1. That means this 7i again will satisfy the definition of a complex number. So very interesting. That means all numbers are the family member of complex numbers. All numbers are family members. So family, the head of the family of number system is complex number. The head of the family of complex number system, head of the family in number system is complex number. That means we can say complex number is the superset. That means the universal set in number system. Complex number is the universal set in number system. Superset of all sets in number system. So ultimately we can say there are three types of complex number. One, general complex number, where the real and imaginary part both are non-zero. Second, purely real complex number, where the real part is non-zero but the imaginary part is 0. And final one is that the imaginary number, purely imaginary complex number, where the real part is 0. One, general complex number, where both the number are non-zero, part are non-zero. Second, purely real complex number, where the imaginary part is 0. Purely real complex number, where the imaginary part is 0. And purely imaginary complex number where the real part is 0. Purely imaginary complex number where the real part is 0. Good. So from again we can say any complex number, if it is the pattern of purely real complex number, then they can be placed along the horizontal line, that is the real line. So that kind of complex number which are purely real, that can be placed along the real axis, along the horizontal line in the organ plane, along the real axis in the organ plane. Every purely real complex number can be placed along the horizontal axis or real axis in the organ plane. In the same manner, every purely imaginary complex number that can be placed along the vertical line or vertical axis or imaginary axis in the organ plane. Every purely imaginary complex number can be placed along the vertical axis or imaginary axis in the organ plane. Every imaginary number can be placed along the vertical axis or imaginary axis in the organ plane. And for general complex number, where all the parts are non-zero, they can be placed either in first, second, third or fourth quadrant. So general complex number can be placed in first, second, third and fourth quadrant. And which one will be where? If both the parts are positive, the number will be in the first quadrant. If both the parts are negative, the number will be the third quadrant. If the real part is positive but the imaginary part is negative, the number will be in the fourth quadrant. And if the real part is negative but the imaginary part is positive, then that will be in the second quadrant. So for both being positive, that will be the first quadrant. For both being negative, that will be in the third quadrant. For the real being positive, imaginary being negative, that will be in the fourth quadrant. And for real being negative, imaginary being positive, that will be the second quadrant. This is the position of complex numbers. By this way, we can place a complex number in the organ plane. By this way, you can express any complex number in the organ plane. So this is the geometrical presentation of complex number. This is the geometrical representation of complex number. Now we will define a new term for complex number, that is conjugate of a complex number. Conjugate of a complex number. That term conjugate is familiar to you. All you know what is the term conjugate, because in the chapter of 𝙎, the term conjugate is introduced first. What is conjugate there? In that chapter, in that topic, conjugate means conjugate of a number suggests that the sign of the irrational part will be changed. Sign of the irrational part will be changed for the conjugate of an irrational number. For the conjugate of an 𝙎, the sign of the irrational part will be changed. Here, for the conjugate of a complex number, the sign of the imaginary part will be changed. In the same manner, for the conjugate of a complex number, the sign of the imaginary part will be changed. So, we have to obtain the conjugate of a complex number, we have to change the sign of its imaginary part. So, first of all, let us introduce the notation of the conjugate of a complex number. For that complex number Z, its conjugate is in general denoted by this or this or this. These are the notation of the conjugate of this complex number Z. Z dash, Z bar and Z power C. So the notation of conjugate of a complex number Z will be in this pattern, either this or this. These are the general notation. But what is the definition? What is the pattern of this? As our definition, this is actually x minus iy, because here the imaginary part was y, and so its sign being changed, we can get the conjugate as x minus iy. So what is the conjugate of z? The conjugate of z, that is x plus iy, is x minus iy. Very easy to remember. Now again, let us find the geometrical significance of the conjugate of a complex number. What is the conjugate of a complex number? What is the position of the conjugate of a complex number? What is the relation between the conjugate of a complex number and it in geometrical relation? What is the geometrical relation? See, what is it? X minus iy. How can we place this x minus iy in this plane? X minus iy means here, if we consider x and y both are positive, then z will be there. And being x and y both positive, here x is a positive value and minus y is a negative value, so it will be below the x-axis with the same distance y, that is negative y, and the position will be this. This is z bar. So what is the relation between z and z bar? Follow the figure. You can easily say what is the relation. Right? The relation is that z and z bar, that means z bar is the x mirror of z. Z bar is the x mirror of z. X mirror of z means mirror image of z with respect to x-axis. Mirror image of z with respect to real axis. So we can say real image of z. X real mirror image of z or x mirror image of z. X image of z. So again a question will arise. If the conjugate of z is z bar, so what is the conjugate of z bar? The mirror image of z bar along x-axis, that means z itself. That means conjugate of a complex number is the number itself. The conjugate of a number is the number itself. Since they are the mirror image with respect to x-axis, so for the conjugate of z bar, we will reach to z. That means the conjugate of a complex number is the number itself. Now a simple question is there. If we want to find out the conjugate of 7 plus 3i, what will be the result? Here what is the imaginary part? We have to change the sign of imaginary part. So what is the imaginary part is there? For 7 plus 3i, the imaginary part is 3. So simply you can say the conjugate is 7 minus 3i. Right? Very good. But if the number is 3i minus 7, then what will be the conjugate? If the number is 3i minus 7, then what will be the conjugate? 3i minus 7. Here the imaginary part is again 3. Positive 3 plus 3. So what is the conjugate of it? The sign of the imaginary part will be changed. That means the sign of 3 will be changed. Here the sign of 3 is positive. So we will get the conjugate as minus 7 minus 3i. Another example. Minus 2 minus 5i. What is the conjugate of it? Very simple, right? Minus 5 is the imaginary part. So its sign if be changed, it will become plus 5. So what will be the conjugate? The conjugate will be minus 2 plus 5i. Next, 5i minus 2. Very easy. 5i minus 2. Achha. Let me do 7i minus 3. 7i minus 3. The conjugate, for the conjugate, first of all we have to see what is the imaginary part. Here the imaginary part is 7. So since 7 is the imaginary part, its sign being changed, it will become minus 7, and so the resultant, that means the conjugate of it will be minus 3 minus 7i. For the complex number 3i, what is the conjugate? Simply, since it is 3i, its conjugate will be minus 3i. What is the result if it is minus 2i? What is the conjugate of minus 2i? Here is one part there, that is imaginary part, and that is minus 2. So the sign being changed for the conjugate, it will become plus 2i. So no problem is there. Now, the final question. What is the conjugate of 4? A purely real number. Purely real number means this is, suppose this is the point 4. Purely real number means that will lie on x-axis, on the real axis. And the significance is that if we want to find out the point of the finger on mirror, then that if you want to find out the image of the point of the finger on the mirror, then that will be there at the same point. So for the x mirror of 4, it will be 4 itself. That means for any real number, its conjugate is the number itself. Again, simply you can say, since here the imaginary part is 0, so its conjugate is the number itself. So for any real number, the conjugate is the number itself. For any real number, the conjugate is the number itself. This is our discussion today. We will discuss more about the rest part of complex number in our next topic. Thank you. Thank you everyone.